NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the Engineering Service Examinations 2023 Prelims Electronics Exam Solutions from Control System subjects. In the previous video, we discussed the same from Electrical Exam Solutions. Okay. So, in this previous video, that means IES 2023 Electrical Exam Solutions from Control System subject, I missed to solve the last questions. So first we will discuss that questions, then we will discuss the electronics exam solutions. So that question is, the graph is given, okay, lead compensation graph. We have to find which of the compensator. We know that lag compensator, lead compensator and lag lead compensator. Lag compensator is high pass filter, lead compensator is low pass filter. So the lead compensation is given. We know the low pass filter graph. Here this B graph is a low pass filter graph. So option B is correct. Okay. Now we will solve this IES 2023 electronics exam solutions from control system subjects. So the first question. The objective of the question is, we have to find the settling time for 5% tolerance span. If you know the del and omega n value, we can find the settling time. So the first objective is to find the del, damping ratio, and omega natural frequency. The trans function is given. If you compare the trans function with the standard sinusoidal trans function, omega n square divided by s square plus 2 del omega ns plus omega n square, we can find the omega n and del. So compare with the standard sinusoidal system. What is the value of omega n square? This is omega n square. So omega n square is equal to 25. So we will get omega n is equal to 5. Then 2 del omega n is 8. So substitute this omega n value here, we will get del value, del is equal to 0.8. So del value is omega n value is known. The settling time formula for the 5% error, Ts equal to 3 by del omega n. Okay. So substitute del and omega n value, directly we can find the settling time. So we can get the answer as 3 by 4. So option B is correct. The second question. The second question is also given in the time domain specifications. Here the objective of the question is, the output response is given. We go to find the trans function of the system. So we know the standard output for a sinusoidal system, y of t for unit step input, y of t is equal to 1 minus e power minus del omega t divided by root of 1 minus del square sin omega t plus pi. This is the standard output for the standard sinusoidal system. Comparing this output with the given, we can get del omega n is equal to 1, exponential term, del omega n is equal to 1. This value is equal to 1 by root of 1 minus del square. So we can get root of 1 minus del square is equal to 3 by 2. Simplify this equation, we can get del and omega n value. From this equation, square on both sides, so we will get 1 minus del square is equal to 3 by 4. Then further simplify, we will get del square value 1 by 4, del is equal to 1 by 2. Damping ratio is known. Now find the omega n from this equation. So omega n is equal to 1 by del. Substitute here, we will get omega n is equal to 2 inverse seconds. Del value, omega n value is known. Then we can easily find the trans function. The standard sinusoidal system trans function is omega n square divided by s square plus 2 del omega ns plus omega n square. This is the standard sinusoidal system. Substitute these values in this equation, we will get 4 by s square plus 2s plus 4. The option D is correct. Okay, third questions. The third question is also from time domain specification. The objective of this question is, we have to find the time taken of the system to reach the 94% of the steady state value. Here R of s is 1 by s, step input is given, trans function of the system is given. Okay. So how to find the steady state value, final steady state value? So y of s by R of s is given, the trans function 1 by s square plus 2s plus 1. R of s is given, step input, just substitute here, we will get y of s value. We go find the y of t. What is steady state value? Steady state means y of t at t is equal to infinite time. This is a steady state value. Y of t at t is equal to infinity. This is steady state value. By the final value theorem, y of t at t is equal to infinite is equal to limit s tends to 0 s into y of s. This is the final value theorem. We know that y of s value, substitute here, we can get the steady state value. So limit s tends to 0, s cancelled, so we will get this. Substitute s equal to 0 in this equation, we will get the answer as 1. So the final value, steady state value is equal to 1. Then what is the value of 94% of final value? 95% of 1 means 0.94. Now we have to find the time taken to reach the final value. So for that we have to find the y of t. We know that y of s value. From that we can find the y of t by applying inverse Laplace. So for applying inverse Laplace, for that simplify this equation, we will get 1 by s plus 1 into s plus 1 into s plus 1. So take partial fraction. For this expression, the partial fraction is a by s plus b by s plus 1 plus c by s plus 1 the whole square. This is the partial fraction. Now find a and b and c value by substituting s equal to 0 or s equal to minus 1, any one values. And we know that partial fraction method. Use the partial fraction method, we can get the answer as a is equal to 1, b is equal to minus 1, c is equal to minus 1. Substitute these values in this equation, we will get y of s is equal to 1 by s minus 1 by s plus 1 minus 1 by s plus 1 the whole square. Now it is easiest to take inverse Laplace. So take inverse Laplace, find y of t is equal to 1 minus e power minus t minus t e power minus t. Okay, we have to find the time taken. So we know that output y of t, substitute here 0.94. By simplifying this equation, we can find the t. That is the time taken to reach the system output to reach 94%. So the time value t is equal to 4.5 seconds. Okay, option C is correct. Then fourth question. What is non-uniform phase transformation? If the system or any one of the poles lies in the head of S plane, then the system is unstable one. Remember that if any one of the poles lies in the right of S plane, the system is unstable. If any one of the zeros lies in the right of S plane, then the system is non-uniform phase system. So option A is correct. Okay. If a zeros lies in the right of S plane, then the system is a non-uniform phase system. Okay. This is a definition. Next, fifth question. Here system poles is given and zeros is given. We go to find the phase system response at 20 Hz. So the formula is P minus Z into minus 90. Here P means number of poles enforces before 20 Hz. Z means number of zeros enforces before 20 Hz. Here totally 3 poles, but 2 poles enforces before 20 Hz. Here the 80 Hz is out. So only 0.7 Hz and 1 Hz are enforces before 20 Hz. So P is equal to 2. In the zeros, 5 Hz only enforces before 20 Hz. So only 1. Substitute here, you will get 2 minus 1 into minus 90. So answer is minus 90. So option A is correct. Next question. The objective of the question is we have to find the transfer function of the system. Here resonant peak is given 20 root 3. Resonance frequency is given 5 in root 2 radian per seconds, but and magnitude 5 is given at 0 radian per seconds. So we know that if we find del and omega value, we can find the transfer function. We know the resonance peak formula. The resonant peak is equal to k by 2 del in root of 1 minus del square. If the system have magnitude k at 0 radian per second, okay, so k means magnitude 0 radian per second, but the standard sinusoidal system have the magnitude at 0 dB per second is 1. So general formula for the resonant peak is MR equal 1 by 2 del in root of 1 minus del square if the magnitude at 0 dB per second is 1. But here magnitude at 0 dB per second is 5. So k is equal to 5. So Now find del value. Here resonant peak value 10 by root 3 is given, K value is 5. So simply this equation will get del value timing ratio del is equal to 0.5. Okay, 0.5 is known. Now we got to find the omega n value. Resonant frequency is given 5 root radian per seconds. The formula for the resonant frequency omega r is equal to omega n in root of 1 minus 2 del square. Del value is known. Okay, 0.5. Substitute here. You can find the omega n value. Omega r value is 5 in root 2. So substitute here. We will get this omega n is equal to 10 radian per seconds. Del value and omega n value is known. Now find the transfer function. The system has magnitude 5 at 0 per second. So the transfer function of the system is J is equal to K into omega n square divided by S square plus 2 del omega n s plus omega n square. How is that the K value? Because at 0 radian per second, if omega is equal to 0, the magnitude is K. Okay, so J is equal to 5, K value 5, omega n square value 10 square. Substitute here, we will get answer as 500 divided by S square plus 10s plus 100. So option C is correct. Okay, if the system is J is equal to omega n square divided by S square plus 2 del omega n s plus omega n square, then the resonance peak formula is MR is equal to 1 by 2 del in root of 1 minus del square, because magnitude at 0 radian per second is 1. Okay, K value 1. Next questions. You have to find the formula for the standard notations. Resonant peak formula is 1 by 2 del in root of 1 minus del square. So option C is correct. Next questions. We have to find the phase margin of the system. So phase margin, we know the formula. Phase margin is equal to 180 plus by GC. By GC means base angle at gain crossover frequency. We got to find the gain crossover frequency omega GC. Omega GC means frequency at which the magnitude is in T. We know that how to find the magnitude and phase angle for any transfunction. If you don't know, just refer this video. This is the magnitude for this transfunction. If the magnitude is 1, the omega will be omega GC. Okay, when the magnitude is 1, the frequency will be gain crossover frequency. Now simply with this equation, we will get answer as gain crossover frequency is root 3 radian per second. Okay. Now we go to find the by GC, base angle at omega GC. So find the phase angle for this transfunction. Pi is equal to here 1 by s minus 90 minus tan inverse of omega for this term. So when omega is equal to omega GC, pi will be by GC. Substitute here, we will get by GC is equal to minus 90 minus tan inverse of omega GC. Omega GC value is known. Substitute here, we can get the by GC value. So by GC is equal to minus 90 minus tan inverse of root 3. So answer is minus 150. By GC value is known. Now we can find the phase margin. Phase margin gamma is equal to 180 minus by GC. So we will get answer as 30 degree. So option C is correct. The next questions. The next question also we got to find the phase margin of the given system. The same concepts. Okay, now we will solve. First we got to find the by GC. For the calculation of by GC, omega GC is needed. So first find the omega GC value, magnitude. For the system, for the transfunction, the magnitude is root of 1 plus omega square root of 1 plus omega square plus omega square plus 4. Okay. Now when the magnitude is 1, the omega will be omega GC. Substitute here. Now simply with this equation, we will get the answer as J root 3 radian per seconds. There is no real frequency. So the phase margin of the system is infinity. Okay. So option D is correct. Next questions. What is the transfunction of tachometer? The tachometer function is derivative control. So option A is correct. Here this is the derivative control. This is all integrating. 1 by s means integrating. If the s term is in denominator, it will be a derivative. So option A is correct. Next questions. Here the closed loop transfunction is given. Unity feedback is given. We go to find the open loop DC gain. So G of s by 1 plus J of h of s. Maybe as negative feedback. Maybe negative feedback. So G of s 1 plus J of h of s is given. S plus 4 by s square plus 7s plus 13. We got to find the open loop DC gain. So DC means omega is equal to 0. DC means omega is equal to 0. So if we substitute this omega is equal to 0, we will get G by 1 plus J is equal to 4 by 13. But we need G. G means open loop DC gain. Simply with this equation, find G, that is open loop gain. So we will get G is equal to 4 by 9, that is open loop gain. So option D is correct. Next questions. The objective of the question is we have to find the second peak response. When the second peak will occur? Peak time, second peak time. Transaction is given. So we know the formula for the peak time by omega d. This is a first peak. The time taken to reach first peak. For nth time of peak, Tb is equal to n by omega d. This is nth peak. For second peak, Tb is equal to 2 by omega d. If you know omega d value, we can find this value. Omega d is equal to, we know that omega n root of 1 minus del square. So for the calculation of omega d, time to natural frequency, we need del and omega n value. For this equation, find del and omega n value by comparing this system with standard second order system. So omega n square is equal to 25. So omega n value is equal to 5. 2 del omega n is equal to 8. So del value is equal to 0.8. Del and omega n value is known. Find omega d. Omega d is equal to omega n root of 1 minus del square. Substitute here. We will get omega d is equal to 3. Just substitute these values in the peak. We can get the time taken for the second peak. So Tb is equal to 2 by 3. So answer is B. Option B is correct. Next, last questions. Okay, this is the last questions for the electronics exam questions from control system subjects. We have to find the voltage transfer function for the system. So just apply the voltage division rule for this circuit. By the voltage division rule, output voltage is equal to total voltage into this branch resistance divided by sum of the resistance. So this branch resistance means 1 by Cs, sum of the resistance plus sum of the resistance means R plus 1 by Cs. Okay, this is the voltage division rule formula. We got to find the V2 by V1. V2 by V1 is equal to 1 by R Cs plus 1. So option B is correct. Okay. If you have any doubts in this discussion, kindly post our doubts in our NCM Learning Center WhatsApp group. If you have any materials for your exam preparations, just post. We can give these materials. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You can get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.